Hello dear students and very welcome to IFAS. So students, in today's session we will discuss a very important and very interesting topic of real analysis, that is limit of a sequence and limit point of a sequence. Basically there is a small difference between limit point and limit of a sequence. Okay, firstly we will discuss first definition, which is nothing but the limit point of a sequence, and the another one is limit of a sequence, and at the end we will discuss the difference between limit point and limit of a sequence, and we will discuss it with some part of examples. Okay, so let us start this video with the first definition, that is a limit point of a sequence. So basically, student, let us take one sequence an. Okay, so I have some sequence an. Okay, and I will say a real number alpha. Okay, the real number alpha is called the limit point. Basically, if you have a sequence alpha n, okay, it is nothing but like what? It will be something like alpha 1, alpha 2, alpha 3, and so on. And if you look at any arbitrary real number, we will say that real number is the limit point if it satisfies certain condition. Okay, now we need to discuss that condition first of all. So what is that condition? It says that if for every delta greater than 0, the interval alpha minus delta to alpha plus delta must contains at least infinitely many points of that sequence A. Okay, so basically what we have, that whatever delta we are taking for any delta greater than 0, whatever delta we are taking, okay, if you are taking, let us take, if you are taking delta is equals to, let us say 0.1, what it implies, there will be interval alpha minus 0.1 to alpha plus 0. The definition says for this delta there are infinitely many n for which an belongs to this interval. Okay, for this particular delta there are infinitely many n for infinitely many n which will be the member of alpha minus 0.1 to alpha plus 0.1. But is it true for only delta is equals to 0.1? Answer is no. It should be hold for every delta greater than 0. So if you are taking delta is equals to 0.2, delta is equals to 0.3, still it will work, right? So whatever delta you want to take, you can. And for this delta, what you have to show, the interval alpha minus delta to alpha plus delta must contains infinitely many points of the sequence. Now let us take, you have some delta, let us say delta is equals to 1. Okay, for delta is equals to 1, what we have given, that alpha minus delta to alpha plus delta, if alpha is the limit point of your sequence, this interval must contain infinitely many points of sequence an. So what about the other points, what we can say? So basically let us say there is my alpha and there is alpha plus delta, alpha plus alpha minus delta. So we know that the sequence has infinitely many terms which lie in this interval, but the other terms may or may not be lie in that interval. So we will take some one example after some time, but for this time consider this, that if you are taking any real number alpha, which is my limit point, then for any delta greater than 0, that interval alpha minus delta to alpha plus delta must have infinitely many terms of the sequence, and all other terms, the other terms may be finite or infinite, right? So all other terms will be the member of set that interval or may not be the member of that interval. Okay, so that is the definition of limit point. So if you are taking just you can say take any subset of natural number which is infinite. Let us take twice in it, which is what? Set of even natural numbers. Okay, so if an belongs to alpha minus delta to alpha plus delta, for all n belongs to this set, that is also fine. Why? Because the set twice n is set of all even natural numbers, which is infinite set. So for all n, those are infinitely many since they are all even natural numbers. Okay, for which n belongs to this interval. So here you can take any kind of infinite subset of natural number or natural number. Okay, so this is the definition for limit point of a sequence. Now, what we know, whenever we are saying that on the real line, if alpha is the limit point, then this interval always contains infinitely many points of the sequence. So the other elements of the sequence may or may not belong to the set. So it may be possible that all even terms are there, a2, a4, a6, 8, but all the terms an where n is odd may lie outside the interval. Okay, so maybe there is a1, maybe there is a2, a3, maybe there is a5, maybe there is a7. So that is also possible. It is also possible that the complement of that interval may contain infinitely many terms as well. Okay, this may happen in the definition of limit point, but this will never happen in the definition of limit of a sequence. What it says, let us discuss the definition of limit of a sequence, and after that we will discuss the comparison between them. Okay, so in the definition of limit point, what it says, for every epsilon greater than 0, there exists m belongs to natural number such that this condition hold. What it implies? This implies that minus epsilon less than an minus l is less than epsilon for all n greater equal m. Okay, this is what we have. Now add l on all sides, so l minus epsilon less than an less than l plus epsilon for all n greater equal m. So therefore what we get, an belongs to l minus epsilon to l plus epsilon for all n. So what it implies, clearly implies, again in the definition of limit point we are using delta, in the definition of limit of a sequence we are using epsilon. The terms are same. Okay, because at the end we are taking for any delta greater than 0 and for any epsilon greater than 0. So if you are replacing that epsilon by delta, doesn't matter. Okay, so look at the set. What it says, it says that you can exclude only finitely many terms of the sequence outside that interval. After some, and that finitely many terms are a1, a2, a3, am minus 1. Okay, these are the elements of the sequence which may or may not be the member of this set, but after that term which is am plus 1. Okay, n is equals to m, it becomes am. N is equals to m plus 1, it becomes am plus 1. So am plus 2, all other terms will be the subset of that interval. This is a collection, so this forms a set, and it will be subset of this set. So in the definition, now this is my final statement which is very important. In the definition of limit point of the sequence, the interval L minus epsilon to L plus epsilon contains infinitely many terms of the sequence. Okay, doesn't matter whether the complement of that set contains finitely or infinitely many elements. Okay, in the definition of limit point of a sequence, the interval L minus epsilon to L plus epsilon contains infinitely many terms of the sequence, and in the definition of limit of a sequence, the term L minus epsilon to L plus epsilon excludes at most finitely many points of the sequence. So what are those points? It is a1, a2 up to a minus 1. Only these are the points which may or may not belong to the set. All other points, what I say, that interval L minus epsilon to L plus epsilon excludes finitely many points, at most finitely many points of the sequence. It means all other points lie in that interval. That means all other points an will be belongs to the L minus epsilon to L plus epsilon. So again, if you look at this set, or you can say if you look at this condition, what it says? It says that again there are infinitely, how many natural numbers after any natural number? Let us say if you are taking m is equals to 10, how many natural numbers after 10? There are infinitely many natural numbers. If I am taking m is equals to 10 to the power 10, how many natural numbers after 10 to the power 10? Again infinitely many. So for any m, all n which are greater equal m is always infinite. So there are infinitely many n for which an belongs to this interval, and this is the definition for limit point of sequence. So that L is also limit point of sequence. So whenever L is the limit of sequence, it means L is limit point of a sequence. Okay. Now let us discuss their difference. the first and the very important difference is in the definition of limit point. Whenever we are talking about point, make sure that interval contains infinitely many points. Doesn't matter the type of points. Okay, it may be even number of even natural numbers, it may be odd natural numbers, it may be all natural numbers of the form 3n. Okay, that are multiples of 3. Doesn't matter, just infinitely many natural numbers are there for which an belongs to that interval. But in the definition of limit of a sequence, only finitely many points are outside the interval, all other points lie inside the interval. Okay, this is the definition. Okay, next one. If I'm saying that, okay, if I'm saying that L is a limit, what it means? This interval excludes only finitely many points. So if you are taking any other point here, is it possible that alpha is limit point of that sequence? No, limit point. Why? Because to become a limit point, the interval of this interval must contains infinitely many terms of the sequence. But the all possible terms which are outside this interval is finitely many. So all possible terms which lie in that interval is at most finitely many. Therefore, alpha cannot be limit point. So if L is the limit of the sequence, it should be unique. Okay. So this is what we have written. Limit of sequence is unique. Now the second one, limit point of the sequence may or may not be unique. Why? I will take an example. An is equals to minus 1 to the power n. If n is even, it is 1. If n is odd, it is minus 1. Okay, we will discuss this example later. But what it clearly says, it says that 1 is also limit point, minus 1 is also limit point. So this sequence has more than one limit point. So limit point may or may not be unique. Third, if the sequence, you can say, has a limit, not limit point. If the sequence has a limit, what it says, this set is bounded. Since it is a finite, it is clearly bounded. Now, is it bounded set? Yes, it is a subset of this set, and this one is bounded. So subset of bounded set is bounded. All these kind of terms will lie in that interval. Na? So the collection of all those kind of terms will be the subset of L minus epsilon to L plus epsilon, and it clearly means the set is bounded. This set is bounded, this set is bounded. If you are taking their union, it becomes the range set of sequence which is bounded. So if the sequence has limit, it is bounded always. Is this sequence bounded? The answer is no. I will take a counter example, that 1 if n is even. So it has a limit point. If the sequence has the statement says, if sequence has the limit point, then it may or may not be bounded. Okay, so clearly it repeats in the sequence infinitely many times. Okay, by the way, there is a result for a limit point of sequence. What it says, if the sequence, if any term of sequence or if any real number repeats in the sequence infinitely many times, it becomes limit point. There are two types of limit points. First one, if L is limit point, then either it repeats in the sequence infinitely many times. So there is 1. How many times 1 repeat in the sequence? A2 is 1, A4 is 1, A6 is 1, A8 is 1. For every even suffix, an is 1. So there are infinitely many even suffix, so there are infinitely many 1. So if any real number repeats in the sequence infinitely many times, it becomes limit point. This sequence has a limit point. Is it bounded? I will define a n if n is odd. So clearly it is not a bounded sequence. So if the sequence has a limit point, it may or may not be bounded. And if sequence has limit, it is called convergent sequence. This is the definition for convergent sequence as well. But this may or may not be convergent. Okay, so for convergence, it should have a unique limit point and it should be bounded. So if the sequence has limit, it may or may not be unique. If sequence has limit point, then it may or may not be unique, and sequence may or may not be bounded. So this is not necessarily true. The last one, limit point may or may not be limit of sequence. So here you can take 1. Is it limit of sequence? The answer is no. The reason behind this is, if 1 is the limit, it clearly means sequence has a limit, and if the sequence has limit, it should be bounded. But this is not a bounded sequence, so it is not a limit. So every limit point need not be limit. But as we discussed earlier, that if this situation holds, it clearly means L is the limit. So if we have some limit, then it becomes a limit. Okay, so these are the main 5 differences of limit of a sequence and limit point of a sequence. Now look at the limit points of this sequence. So here what is an? It becomes 1 if n is even. It becomes -1 when n is odd. Okay, so here what we can do here now. So for any delta greater than 0, okay, firstly for every delta greater than 0, 1 belongs to an minus epsilon n minus delta to an plus delta. Not an actually. 1 belongs to 1 minus delta to 1 plus delta. For every, this is always true. For any delta greater than 0, that 1 is always member of, look at the set. There is 1. And if you are taking 1 plus delta, it will be greater than 1. 1 minus delta, it will be less than 1. This number is always lie in that interval. What is 1? It is an is equals to 1, which belongs to 1 minus delta to 1 plus delta for in even n. So an belongs to 1 minus delta to 1 plus delta for all, or not even, for not all, you can say for infinitely many n. How many n are there? There are infinitely many even natural numbers. So for infinitely many n. Okay, and therefore this 1 satisfies the definition, therefore 1 is limit point. Therefore 1 is limit point. So similarly you can show that -1 is also limit point. Just you have to replace even by odd. Okay, so 1 and -1 are the limit point of this. Now the next one, that an is equals to 1. By now we have to check, or let us take homework for you. Give me the answer in comment box, that you have to find the limit point of a sequence and limit of a sequence if it exists. Okay, so these two are okay. So now this is our CSIR NET learn free section, okay, which is a very famous in India. All CSIR NET aspirants visiting this website, www.ifasonline.com, and you will get all required information for the CS to qualify CSIR NET exam in this one app, or you can say one official website. Okay, there is only one stop destination of your content. If you want CSIR NET exam previous year questions paper, if you want CSIR NET exam previous year questions paper topic wise analysis, if you want exam cutoff, if you want that CSIR NET exam pattern, CSIR NET syllabus, CSIR NET important dates for upcoming CSIR NET exam, and if you want to do some test, okay, for your preparation, then all these available on our IFS free app, as well as there are previous year questions paper of GATE exam, SET exam, NBHM exam, TIFR exam, CET, PG, as well as IIT JAM, as well as PSC exam. All the previous year questions paper are freely available in our IFS app. There are almost 175 previous year questions paper which are available freely in our IFS app. What you have to do, you have to simply register in our IFS app. For that, just visit www.ifasonline.com. After that, just there is the login option. You can log in there with the help of your mobile number and your OTP, and just add some your basic information, that where are you from, okay, your name, as well as your course, okay, that course you are interested in. So what you have to do, you just have to register there and get all these data freely in our IFS, okay. As well as if you want to buy any English recorded course, there is a English recorded course which is 3,999, which is a very minimal price for your 6-month preparation, and you have to use the promo code India, okay. So go and visit www.ifasonline.com and purchase our course, as well as visit learn free section and explore there, all collect all data like CSIR NET exam previous year questions paper, topical analysis, and so on. Okay, so this is our results. Around 1200 plus IFSN students qualified in December 2023 exam. So if you want to qualify, just visit IFAS website and purchase our course. Okay, so thank you so much and have a